Okay, in the previous video we have seen how to construct the residual network with the help of the original flow network, and it's going to be crucial in the Ford Fulkerson algorithm. So let's see what is this algorithm, and first of all, what is an augmenting path. It only exists in the residual, so in the G prime network. It is a simple path from S to T in the residual network. It's very important that the starting vertex is going to be the source, the end vertex is going to be the sink, and basically any path that's going to connect S with T is going to be an augmenting path. If there is an augmenting path in G prime, then we know for certain that the flow in the original G network is not maximal. So we have to iterate through, we have to continue with our algorithm. But if there is no more augmenting path in G prime, it means that we can terminate the algorithm. So if we are not able to find any more path in the residual network, it means that this is the end of the algorithm. We have found the maximum flow. Okay, so what about the Ford Fulkerson algorithm? First of all, we have to initialize the flow in the flow network to be 0 at the beginning. Basically, it is done in the G, so in the original network. So the FUV, which is the flow, is initialized to be 0 for all the UV in V, which means that we iterate through all the edges, because basically we are able to assign a flow value to every edge where the starting vertex is U and the end vertex is V. We define an edge with the help of two vertices, of course. And while there is a path from S to T in G prime residual network, then we have to find that given augmenting path P, and we have to augment the F flow along the path P in the G flow network. This is what I have been talking about, that okay, first we have to look for the augmenting path in the residual network. We calculate that is it possible to flow some unit over the edges. And if it's possible, then we are going to update with these updated flow parameters, and we are going to update the edges of the original G flow network, and basically we keep iterating while we can find any more augmenting path in the residual network. Okay, so we initialize all the flow variables to be 0 at the beginning. We construct the residual network, we search for an augmenting path, then we update the original graph. Then we construct the updated residual graph according to the flow network, and we try to find another augmenting path. Okay, then if we are able to find it, then we update the original G flow network, and because the original network has changed, that's why we have to update the residual network as well, and we have to construct it over and over again, because the edges are going to be changed from iteration to iteration. Okay, and what about the Admon Scorp algorithm? We know from Ford Fulkerson algorithm that we have to find the augmenting path in the residual network. But there are several graph traversal algorithms out there to traverse a graph, such as depth first search, A-star search, nearest neighbor search, breadth first search. Okay, what to use? An Admon Scorp algorithm uses BFS or breadth first search to find these augmenting paths, and it turns out to be the best graph traversal algorithm to be used. The running time of Admon Scorp algorithm is going to be ordo V times E squared, where the E denotes the number of edges and the V denotes the number of vertices in the graph. Usually we have more edges than vertices, so that's why E is greater than V. So the running time of Dinic algorithm is going to be better. It's going to be ordo V squared E, which is going to be better because E is greater than V. Okay, we are going to implement Admon Scorp algorithm with breadth first search together. Thanks for watching.